at LG Institute of Engineering and Technology. Today we are going to discuss few more topics of Laplace transform. So let's begin with the first topic, that is solution of ordinary differential equation. So if Laplace transform of yt is equal to capital Ys, then Laplace transform of y dash t is equal to sys minus y of 0. This formula we have already studied. Okay. Then Laplace transform of y double dash t is what? S square ys minus sy0 minus y dash 0. Okay. And in general we have this formula. Okay. So we will use this formula to solve the ordinary differential equation. So let's begin with the example. Now here we have y double dash plus 6y dash is equals to 1 and y of 0 is equal to 2 and y dash of 0 is equal to 0 is given. Okay, so this equation is given. Firstly, what we have to do, we have to apply Laplace transform everywhere. Okay, and we'll apply the linearity property. So we can split like this. Now we'll apply the formula of Laplace transform of y double dash, that is s square ys minus sy0 minus y dash 0. Okay, plus 6. Now we'll apply the formula of Laplace transform of y dash, that is sys minus y of 0. Okay, is equals to Laplace transform of 1, that is 1 upon s. Okay, now what we will do, we'll bring this ys together. Okay, so here we have s square plus 6s ys. Okay, now y of 0 is what? 2. So here we'll get minus 2s and y dash 0, it is what? 0. So here we have to substitute 0. Okay, and from this also again y of 0, that is 2. So 6 into minus 2, it will give you minus 12. Okay, and this is equal to 1 upon s. Now bring this to minus 2s plus 12 over this side. Okay, so what you will get? 1 upon s plus 2s plus 12. Okay, simplify this. So this is 2s square plus 12s. Okay, plus 1 upon s, and here we have s square plus 6s into ys. Okay, so from this we will make ys as a subject. So what you will get? 2s square plus 12s plus 1 upon s we have. Okay, and take s common from this. So here we'll get s square. Okay, and here we will have s plus 6. Now this is our ys. So what we have to do, we have to find y of t. Okay, so for that what we have to do, we have to find the Laplace inverse of this term. Okay, so for that we will apply this partial fraction method. Okay, so what is given? Ys is, let's see, let's write ys once again. So ys is what? 2s square plus 12s 2s square plus 12s plus 1 upon s square into s plus 6. Okay, this is the ys. Now we'll use the partial fraction method. So here we have this term. So for s square we will write a upon s plus b upon s square. These are the repeating roots. Okay, and for 1 upon s plus 6 we will write c upon s plus 6. Okay, now just cross multiply. Okay, so what you will get over here? As into s plus 6 plus b into s plus 6. Okay, plus cs square, right? And here we have 2s square plus 12s plus 1. Now we know how to find the value of a, b and c. So if you will substitute s is equal to minus 6, okay, we have to substitute s is equal to minus 6. So this two term will be gone. Okay, and from this what you will get? Substitute. So here 2 into 36 plus 12 into minus 6 plus 1 is equal to what? Here you will get 36c. Now on simplification we'll get the answer of c as 1 upon 36. Next we'll substitute s is equals to 0. Okay, so if you will substitute s is equal to 0, this term will be gone, this term will be gone. From here we have 1 is equal to what you will get? Here b 6b. Okay, so you will get b as 1 upon 6. And to find the another term, okay, we have C and B. So to find A, what we'll do, we'll substitute S is equals to 1. Okay, so on substituting S is equal to 1, what you will get over here, 2 plus 12 plus 1. Okay, and just substitute over here, so you will get 7A. Okay, plus here you will get 7B plus C. Substitute the value of B, that is 1 upon 6. So 7A plus 7 upon 6 plus C. Okay, simplify this. So you will get, also we know the answer of C is what, 1 upon 36. Okay, simplify everything. So you will get the answer of A as 71 upon 36. Correct? Now I'll substitute the answer of A, B and C over here. So what you will get here, and apply the Laplace inverse. So Laplace inverse of 2s square plus 12s plus 1 upon s square into s plus 6. Okay, so this is what, A is 71 upon 36. So 71 upon 36 into 1 upon s, plus answer of B is 1 upon 6. So 1 upon 6 into 1 upon s square, plus answer of C is 1 upon 36. So 1 upon 36 into 1 upon s plus 6. Now we have to just find the Laplace inverse of this term. Okay, so 71 upon 36 as it is, Laplace inverse of 1 upon s is what, 1, plus 1 upon 6 as it is. Laplace inverse of 1 upon s square is what, t, plus 1 upon 36 as it is, and Laplace inverse of 1 upon s plus 6 is e raised to minus 6t. Okay, so this is your final answer. So here you got y of t. Okay, so this is the solution of the given differential equation. Now let's solve one more example. Solve y double dash plus y is equal to sine 2t. Y of 0 is 2 given and y dash of 0 is 1 given. Okay, so same method, just apply Laplace transform to both the side. Okay, so what you will get here, or from this Laplace transform of y double dash, that is s square ys, okay, minus sy0 minus y dash 0, plus Laplace transform of y is what, y of s is equal to Laplace transform of sine 2t, that is 2 upon s square plus 4. Okay, bring this ys term together, so we have s square plus 1 ys minus y of 0 is 2, so we have minus 2s, and y dash 0 is 1, so we have minus 1 is equal to 2 upon s square plus 4. Now s square plus 1 ys as it is. Okay, bring this 2s minus 1 over here, so we have 2 upon s square plus 4 plus 2s plus 1, and next we'll bring this s square plus 1 in the denominator, so you will get ys as 2 upon s square plus 4 s square plus 1, okay, and plus 2s upon s square plus 1 upon 1 upon s square plus 1. Okay, like this. Now this is your ys. Now what we have to do, we have to find the Laplace inverse of this term, okay, in order to get yt. Now y of s is what, 2 upon s square plus 4 s square plus 1, okay, plus 2s upon s square plus 1 plus 1 upon s square plus 1. Now we have to simplify this. Okay, so what we will do, will not solve using partial fraction. What we will do, we'll try to simplify as it is. Okay, so we can write it like this, s square plus 1, okay, minus s square plus 4. If you will write it like this, okay, so what you will get, this s square will get cancelled, 1 minus 4, it will give you minus 3. Okay, so what we will do, we'll multiply and divide it by minus 3. Okay, and here we have s square plus 4 s square plus 1, right, plus 2s upon s square plus 1 plus 1 upon s square plus 1 as it is. Now simplify this, so what you will get, minus 2 upon 3. Now s square plus 1 will get cancelled. Okay, so what we have, 1 upon s square plus 4 over here, minus, now s square plus 4 will get cancelled, so 1 upon s square plus 1 plus 2s upon s square plus 1 plus 1 upon s square plus 1. Now we'll find the Laplace inverse. Okay, so minus 2 upon 3. Laplace inverse of this term is what, 1 upon 2 sine 2t. Okay, minus Laplace inverse of this term is what, sine t, plus 2 as it is. Laplace inverse of s upon s square plus 1 is cos t, and Laplace inverse of this term is what? Sin t. Okay, just do some simplification. So this 2 cos t I will write here. Okay, now multiply this, so this 2 will get cancelled, so we have minus 1 upon 3 sin 2t. Okay, multiply this, so we have plus 2 upon 3 sin t. Okay, and plus again sin t. Do one more simplification. Okay, so what you will get? 2 cos t minus 1 upon 3 sin 2t. Here takes sin t outside, so 2 by 3 plus 1, it will give you 5 by 3. So 5 by 3 sin t. This is your yt, which is a solution of given ordinary equation, right? Now let's see one more example. Solve the following differential equation using Laplace transform. Now here you can see we have two equations, dx by dt plus y is equal to sin t and dy by dt plus x is equal to cos t. The value of x at 0 is 0 and y at 0 is 2. Okay. Now we have this equation, that is dx by dt plus y is equal to sin t. Now apply Laplace transform. Okay. So this is x dash t. This is x dash t plus y is equal to sin t. So on applying the Laplace transform, what you will get? Laplace transform of x dash t plus Laplace transform of y is equal to Laplace transform of sin t. Okay, so from this what you will get? Sxs. Okay, now here we are in terms of x, so we'll write xs minus x of 0. Okay, plus Laplace transform of y is what? Ys, and Laplace transform of sin t is what? 1 upon x square plus 1. Now we know that x of 0 is 0, so this term is gone, and we have Sxs plus y of s is equal to 1 upon x square plus 1. Now we have another equation. This is dy by dt plus x is equal to cos t. Okay, so this is y dash t plus x is equal to cos t, right? Apply the Laplace transform. So what you will get here? Sys minus y of 0 plus Laplace transform of s. X will give you xs is equal to Laplace transform of cos t, that is s upon s square plus 1. Now we know that y of 0 is what? 2. Right, so substitute. So s ys plus xs is equal to s upon s square plus 1. Okay, y of 0 is 2, so bring over here, so we have plus 2. Now we have this equation number 1, equation number 2. So what we have to do? We have to simplify this two equation, and we have to find xs or ys, and then we have to simplify individually. Okay, so firstly we will write this equation 1 and equation 2 again. So sxs plus ys, sxs plus ys is equal to what? It is 1 upon s square plus 1, 1 upon s square plus 1. Okay, and the next equation is what? Sys plus xs, sys plus xs is equal to what? It is s upon s square plus 1 plus 2, s upon s square plus 1 plus 2. Now what we will do? We'll multiply by s to this equation. Okay, so what you will get here? You will get s square, you will get s over here, and you will get s over here also. Okay, we have just multiplied it by s. Okay, multiply by s, so we will get this. Now we'll subtract this. Okay, so this term will be gone, and take xs common. So s square minus 1xs is equal to what? These two term will get cancelled, so what remains is minus 2. Okay, so your xs is what? Minus 2 upon s square minus 1. Now we have xs, so we can find xt by taking Laplace inverse. Minus 2 is constant. Laplace inverse of 1 upon s square minus 1. Now here we have minus sign, so this is hyperbolic function. Okay, we have constant in the numerator, so this is minus 2 sine ht. Okay, now what we have to do? We have to find ys. Okay, now we have this equation, that is sxs plus ys is equal to 1 upon s square plus 1. This is equation number 1. Okay, in this equation number 1, we'll make ys as a subject. So 1 upon s square plus 1 minus sxs. Xs is what? Minus 2 upon s square plus 1. Okay, so bring this side, so we have plus 2s upon s square minus 1. This is your y of s. Okay, what we have done, we have just substitute the value of xs from this term. Okay, now we need to find y of t. So what we have to do, we have to find the Laplace inverse of this term. Now Laplace inverse of 1 upon s square plus 1 is what? Sin t. Okay, and Laplace inverse of 2 is constant, so 2 as it is. S upon s square minus 1 is what? Cos h t. Okay, so your yt is this, okay, and xt is this. So this is the solution of ordinary differential equation, right? I hope you have understood throughout the section. Thank you for watching.